So you're stuck real bad, but don't be sad. Mark is here to help you escape from ALEKS. There's gonna be some yummy pie filling.
Hey, well, hi, everybody. Hi, Mike here. We're going to do another calorimetry problem. We just got kind of another video. We did one where we were trying to find the specific heat capacity of something. This one's a little bit of a switcheroo. We are going to find the equilibrium temperature of two things that are put together. I don't know. It looks like here we've got a piece of glass that's dropped into a container. Let's draw a little cartoon of that, huh? So we're going to take a piece of glass and we are going to drop it into an insulated container with 250 grams of water. So, okay, coffee cup, insulated container. We got 250 grams of water, and it's at a temperature that is, let's see, warm. And we're going to take a piece of glass, which is cold. Well, that's kind of juicy. Usually we take a hot piece of something, put it into something. So this is going to be, right straight out of the refrigerator. And then boom, we're going to put it into some warm water and they are going to trade heat. In this case, what's going to happen is warm water at 60 degrees is going to give heat to the piece of glass. And once again, it's the same sort of setup. We're going to go ahead and say, well, hey, if you give me a heat capacity, apparently my weapon, swing, is Q equals MC delta T. As a matter of fact, whenever you see the word specific heat capacity or just heat, you might want to whip that thing out. And then what we're going to do is we're going to say, okay, we're going to assume no heat is lost to the surroundings. So we're going to say Q glass is equal to negative Q water or vice versa. All right, you can do either one. We can say negative Q glass. Why can you do either one? Well, one of the delta T's is going to be negative and one is going to be positive, and they will end up canceling out the negative signs. However, you do have to be very careful that you put one of those sides of the equal signs, got to have a negative sign. We did another video where we were finding the specific heat capacity of something, and specific heat capacities are negative, never negative, excuse me, but a delta T, in the case of this, one's going to be positive, the other is going to be negative. So we got to be really careful with our delta T's signs. All right. In this case, the delta T of the water, which is kind of unusual. Usually you take a warm substance, put it in, water, and it heats up. Both of them heat up, get to the same temperature. Okay. And, in this case, this is a little different. It's okay. So, all right, cool. Let's go and set that up. Now, what we're going to do is we're going to say M glass, C glass, delta T glass is equal to M water, C water. And now, once again, they haven't given us the specific heat capacity of water, but trust me, gang, it's very well documented as being 4.184 joules per gram per degree C. All right, that's what that's going to be. So let's set this up. And by the way, it doesn't matter what's on the left, what's on the right of the equal sign. It's all going to come out. Just got to be careful with your delta T's. So let's go ahead and say, all right, M glass times C glass. In this case, it was given, times the delta T of the glass. And let's see, let me say I use that top expression up there where the negative sign was on the right, equals negative M water. Just setting this up symbolically so you can see this is the starting point of all these kinds of problems. And so times the delta T of the water. Make sure we don't get our delta T's jacked up. So what happens here? After we plunk in the piece of glass, they're both going to end up, this is going to be, the water is going to be, T initial is going to be 60 degrees. And they didn't tell us the final degree C. We're going to have to calculate the finals. This thing was T initial of 3.7. And so now what we're going to do, gang, is T final for both of them is big ol' question mark. And it's got to be in degree C, correct number of significant figures. Okay, well, we're going to end up subtracting. I think the significant figures are going to work out just fine. Now, here's the thing. If you jack this up by getting the negative not in there or something, we know that this range has to be within, it has to be within 60 degrees to 3.7, right? And another thing, the glass weighs less and glass has a smaller heat capacity. So the final temperature, whatever this TF is, whatever this final temperature is going to be closer to that of the warm water than that of the cool glass. Because the cool glass, you know, it's got roughly, I don't know, less than less than a tenth of the mass of the water, and the heat capacity of water, as always, is the biggest thing in the world. So here's how we're going to set this up, guys. We're going to set this up by being careful that we take our mass of our glass, okay, 19.0 grams. They told us the specific heat capacity of glass. This particular kind of glass, I'm sure all kinds of glasses have different heat capacities. Joule, 0.670 joules per gram per degree C. All right. Times, okay, this is really important. Times final minus initial. We don't know final. We're going to call it X. X degree C minus the initial of the glass was 3.7. All right. Now that is equal to, let me stretch out my box thingy, to negative 250 grams, 250.0 grams, mass of the water, heat capacity of water, 4.184 joules per gram times degree C, times the delta T, X minus 60.0 degrees C. So you see, the X is the same. Now, here's what I'm going to do, and this might surprise you folks. As much as I'm a unit freak, I'm going to lose the units because X is going to be in degrees C, and it's just going to add a lot of clutter to this. So I'm just going to say, okay, look, if I do this right now, joules per grams per degree Celsius cancel on both sides. The grams cancel, and I encourage you to always tag the units with the number. But in this case, I think we just need to make sure that we do our algebra appropriately, okay? So because this is now a big old algebra problem. This is, as a matter of fact, I'm going to go ahead and say, let's do 19.0 times 0.670 is 12.73. I'm not putting the units in there. 12.73 times X minus 3.7 equals 250 times 4.184 is 1,046. Negative, though, negative 1,046 times X minus 60.0. Okay, now I need to distribute. Sound like a math teacher now, all right? So 12.73x minus 12.73 times 3.7. 47.101. I'm going to keep all the digits I can until the end, all right? 47.101 equals negative 1046x minus, okay, look what I did. I almost missed the minus sign. That would have been a nightmare. Got to really pay attention. The only excuse I got is I can say, well, I was talking, I was trying to pay attention to what I was saying. 1046 times 60, and that should be positive because negative 1046 times negative 60, so, and it's gigantic. 62, see, this is easy to get lost, but you got to remember, my number, my answer better be between 3.7 and 60. And it better be closer to 60 than 3.7. So you have a bailout here. If you have a way of, figuring out, what's going on here. Now, okay, let's collect all our X's on the same side just to, let's just choose one task at a time. So what I'm going to do is I'm going to take both sides of the equal sign and I'm going to add 1046x. All right. And of course, what that will do is that will get rid of the X's on the right. And now I've run out of space. I'm going to have to go over here and rewrite this. 12.73 plus 1046. That is 1,058. 1,058.73x minus 47.101 equals minus 62,760. Now let's get all the let's get the 47.101 and get rid of that, the negative 47.101, and get rid of that in a hurry. Okay. And what did I do? I know what I did. That should have been a positive 1046. I looked at it and I said, that doesn't make sense. It should be plus. You probably caught me. That's good. I could always say I did it on purpose, but I didn't. I caught myself. And that's the thing, is you're going to goof up, but you got to ungoof it up. I looked at that and I said, how is X going to be negative? Because it's got to be in that range, 3.7 to 60, and it's got to be closer to 60. And now it's going to get a negative number because I goofed it up. Here I am. You're relying on me to get everything right. I still did because I discovered that I didn't do something wrong. And I'm not trying to pat myself on the back. I feel a decent amount of shame for what I just did there. You want to be flawless, but maybe the fact that I goofed something up might say, hey, this guy has been doing this for 32 years and he goofed it up. Nothing wrong with goofing it up. Just got to ungoof it up. So let's see what happens here. That gets rid of that. Add these two together. And finally, we're almost there, gang. 1058.73x equals 62,760 plus 47.101 is 62,807.101. let's divide that number by 1058.73. And I get on my calculator, I have to make some room for this, 59.323. I'm going to quit soon. 05781. That's what my calculator says. Calculator doesn't know significant figures, right? Now, you see, because that term, though, the delta T, the last thing we solved for, that's subtraction. And in order to follow the correct rule of significant figures, we have to say that, okay, look, it's a temperature. You know, both these temperatures were good to the decimal place is what you care about when you're doing subtraction, to a tenth, right? So this is going to be 59.3 degrees when we get all said and done. And you say, whoa, that was really close to the original temperature of water. Does that sound right? Yeah, it sounds okay to me. The mass of the glass was, you know, like if you think about it, let's say that it was water that was 19 grams. You know, 19 grams is more than 10 times less. So the mass was less. And then the heat capacity difference is like, you know, whatever 4.14184 divided by 0.67. 0.67. It's a lot. 4.184 divided by 0.67. The heat capacity of glass is, or water is like 6 times greater. It outweighs, the water outweighs it by more than tenfold. So this should be like even less than a 60th between. So I'm feeling good about myself. 59.3, final answer. Okay. A little bit of a mess. It's okay. We stuck with it. I lost a negative sign. I found out the step after I looked at it and I knew I was going to get a negative X, which is impossible. And I didn't panic, even though I'm in the business of looking like I didn't panic. I'm not panicking. I didn't panic. So that's that. Let's try another one, shall we? Any questions? Drop them in the comments or berate me for, you know, missing that negative sign. I'll try not to do it again. Here we go. Show me another fine, Alex, and make it different somehow. Make it something different. Aluminum. Okay, well, we'll do this one. We'll do this one. No, we already did something with aluminum in it. Ooh. Okay. 15 grams of cream added to 100 grams of coffee. Okay, cool. Finals week, you go to the coffee shop, you do this, right? You get a little gizmo of cream. Actually, if you go to the fancy places, they put it in for you. No, you say, I want room for cream, you know, and then you put your cream in. Cream's cold, 15 point, I hope it's cold, 15.4 degrees Celsius is the cream in the coffee. Now, they didn't give us the specific heat capacity of cream, so they're taking a wild leap here. And they're saying that, let me read this. No heat's lost to the cup or surroundings, which, to be honest with you, styrofoam cups are not cool nowadays. It's got to be paper. But they're saying that the specific heat capacity of cream and coffee are the same thing. I bet you that's a pretty, cream has a lot of fat in it. But hey, they want to make it simpler on us. That means both of these are going to be the same thing. That means on both sides of the equal sign, they cancel out. This is going to be easier. So, okay, cool. I hope you get this one out of your 3. So we're going to say Q cream is equal to negative Q. I have to call it, darn, they're both C's. I'll call it water. Okay. So Q cream is negative Q water. That means I need MC delta T on both sides. M of the cream, C of the cream, delta T cream equals, I won't forget it this time, negative mass of the coffee, which I'm going to call water, C of water, delta T of water. I'm saying water is coffee, okay? And W means coffee, and C means cream. Then they say, okay, you can assume that both are going to be the same characteristics of water. So that means we get lucky. We only have to put in here, we could just say they're equal. You could put 4.184 on both sides if you wanted to make life a little more difficult for yourself. I don't want to do it. So what we got here, we got our coffee cup. This is something you can imagine because a lot of us do this. You know, you got our hot coffee. How much did it weigh? 100 grams. Not much, must be espresso, fancy, right? If you think that 12 ounces is 354 fluid ounces, isn't that much? It's a little bit of coffee. We're going to throw 15 grams of something cold in there. And this time, it's the masses that are really going to be the difference. The heat capacities aren't going to be different. So this is one you want to get for yourself. So here we go. Let's put some numbers in. And by the way, when we get done, my temperature is going to be to a tenth. When we get done, doggone it, you can pretty much just do this almost in your head. We're going to be about a sixth of the way, 100 divided by 15. We're going to be a sixth of the way between 84 degrees and 15.4 degrees. So, you know, we're going to be closer to 84 degrees, which is super hot for coffee, by the way. They better be careful you don't spill this in your lap. You better put some cream in this in a hurry. All right. And you're going to be closer at the end to the 84 degrees if we do our thing right. Okay. So we got 15 grams. Like the last one, I'm going to drop the units. Okay. 15.0. Got it. You know, just for the sake of times C, which is the same thing, times delta T, which is we're going to call final minus initial. The initial temperature of the cream was 15.4. I'm going to lose the units here. Equals minus 100.0 grams. I put it in parentheses over there on the left, so I'm going to do it on the right. Times X. They're both going to get to the same X. Minus 84.0. And the thing is, we're going to solve for X. So let's go ahead and distribute the X. 15.0 X minus 15.0 times 15.4 is 231 equals, I'm going to go ahead and say minus 100x and then plus 100 times 84. I don't know why I'm doing that on my calculator. Just sues me. I knew it was 8,400. Positive 8,400 because of that negative sign. Negative 100 times negative 84. Remember, if you do what I was going to do in the last one, if you do something wrong, it'll come out in the wash here. So here we go. Let's get all our x's collected on one side. Let's add 100x to both sides. Right? That cleans things up nicely. And then we get 115x 115.0x. I know what I'm going to do with the digits at the end. I'm going to make it good to a tenth, just like the last one. 115x minus 231 equals 8,400. All right. Let's go get rid of the negative 231 by adding to both sides 231. And I've run out of room a little bit, so just let me do this over here. 115.0x equals 8,400 plus 231, 8631. Remember, we get to judge this. This better be between 84 degrees and 15.4 degrees. Doggone it, did I do that? Yeah, okay. 15.4 degrees. And also, this better be, about a sixth of the way through. So 8631 divided by 115. 75.0. Remember, I'm going to include all the digits because that's what your calculator does, and tell you that you don't have to worry about it. 17391. Oh, you got to make it difficult, don't you, ALEKS? Like right on 0.5 and just a little bit above. X is 75 because all of the temperatures were in degrees Celsius to the 10th of a degree Celsius. My answer, I'm not going to put it in the box yet. I'm going to dwell on it. Anyhow, thanks for putting up with my rambling at the end. Got one that's given you some sort of angst? Give me a comment and we'll get working on it. I'm trying to do these right now because this is about where in the semester at this time of year we're doing thermal chemistry. But if you discover this a year later and it helped you out, let me know. Give me a thumbs up. Smash the subscribe button. Bang the bell. Whatever you got to do. It's your life. So have a good rest of your day and toodaloo.
There's gonna be some young